It has my like name and stuff. That's the coolest thing. Look at that. Look, that's amazing. Hi everybody. I'm Tejas. That's pronounced like contagious disease. I'm not contagious, at least to the best of my knowledge. I did a COVID test. I couldn't make this joke during the lockdowns. Can you imagine? That would have been super awkward. But anyway, just to help you pronounce the name, it's like contagious. And I've been working in tech for many, many, many years. I've been speaking at events for the past 11 years. I've been building on the web professionally for the past, I don't know, like 15 plus years. I've been writing code since I was 8 years old. And over that time, I've had the privilege of working at some of the best, at or with, in some capacity, some of the best companies and teams in the industry. And really, the work we do together is amazing and fun, and I'm super thankful for it. And it's based on all of this work that I'm here to talk to you today about front trends. Front-end trends. I tried. Did it work? No. Damn it. Someone said no even. Wow. Chose violence today. Anyway, this talk is about the trending topics in the front-end world today. And you know what? The space moves really fast. I'm just joking, of course. I checked everything up until the hour before the talk, and it should still be appropriate information. But of course, in the event that you're watching on video or something and it's outdated, I'm on the socials. I share updates there as well. But I'm not an authoritative source. Honestly, like there's smarter people you can follow, so it doesn't really matter. But front trends. Okay, what are we talking about in terms of front ends? And the plan of action today is to help you know what's happening in the front-end space so that when you hear conversations, you don't feel imposter syndrome. You don't feel like, oh, I have nothing to contribute. You don't feel like, yeah, I should maybe pretend I know this thing, even though I don't, because I'm scared of looking dumb, right? That's a thing in the industry. And my goal here today is not to tell you, go use this or use that or sell you anything. My goal is to give you enough context and knowledge so that when you hear an interesting conversation, you can participate. And you can participate with confidence. That's really the name of the game, is we eliminate some of that doubt and imposter syndrome and uncertainty, and we give you confidence. We give you confidence through context, okay, across a broad range of topics. The range of topics is very broad. That's why it's quite long. It's 45 minutes. And if we run out of time, we'll have a big summary at the end, okay? To get started, let's talk about front-end and back-end. These are relatively new terms, all things relative, because like when I was getting started, there was webmaster. As the webmaster did everything on the web. You build your MySQL databases, you maintain them, you write some PHP, and like you kind of do everything. That's no longer the case, thankfully. We got more specialized. We recognized that, wait, front-end actually has a different set of constraints, mainly because front-ends run in an environment that is like an alien planet, right? They run in your phone, in your browser, on your laptop. Back-ends, you control everything. You're like, I have these machines, these virtual machines, these databases, they all live in my data center. Right? So it's a different set of constraints. Moreover, front-end is used by a wide variety of people. People with color blindness, people with hearing impairments, people like the human race is diverse and beautiful, and front-end has this as a constraint to engineer against. Back-end, again, you control everything, including the back-end engineers working on your team. So the constraints are different, therefore specializations emerged, okay? Let's really nail down what this looks like, because front-end encompasses UX, UI, design, and finally the code that makes it to your user's device, browser, phone, whatever. That's a broad range. But the boundary is the user. If we think about back-end, it's a very broad topic. There's clouds, which is like clusters of machines. There's the whole DevOps side of making sure everything's running and scaling well. There's the data side where you're not only engineering data, but storing data. There's the APIs, that is the interface between the users, the clients, and the server. There's all of these different layers of complexity. And this is a trend. I'm talking to you about this because there's a trend in both front-end and back-end merging. We look at that. And front-end and back-end diverging. These are both happening in parallel at the same time. And what we'll talk about today is how that's happening. I'd like to do that by showing you one demo. There's multiple demos today, but one demo about this where the front-end and back-end are kind of diverging. Last year in 2022, a big trend was back-ends as a service, things like Supabase. I mean, Supabase, anyone heard of Supabase? Okay, yeah, Supabase started in 2020. It was like a COVID project. The founders built it in the middle of the pandemic and in the middle of the lockdown. It's kind of nuts. It's a great story. Supabase, Zeta, PlanetScale, these are all backends as a service, and they all kind of started last year, and they help make the front-end engineer's job easier by saying, we'll handle all of that, and you handle the user interface, the user experience, etc. Okay? I'd like to show you one of these services today that's brand new, and this is why it's a trend. It's brand new, and it's a different way to doing backends as a service that can really help you move forward as a front-end engineer. The tool is called Keel, K-E-E-L, Keel. And Keel is similar to Supabase, Firebase, etc. However, there's one difference, and that is your entire backend in Keel, as it says here, is a single file. And so if we look at Keel code, this schema represents an entire backend system. Databases, APIs, authentication, authorization, everything. And how it looks is you have a model user, and a user model has these fields. These are similar to columns in a database. I'm sorry if you can't see from that side. This room wasn't made to be that wide. Hopefully you'll catch the recording after. Actions. Actions are things you can do on these fields. So you can create, in the case of a user model, you can create a user, get a user, update a user. Similarly, there's a bunch of other things that you can do, right? But this is kind of the schema. So once you define your backend as a bunch of models and fields, in this file, you use Git and you push it to a GitHub repository. And then you come to the Keel console, and it builds that as a full backend. So these are my commits. And if you come here, you can see that I made this commit on 7th of November, and it validates my schema and turns my schema into a full deployment and a database and functions and everything. That file becomes infrastructure. In fact, I come to the database side, and I can actually see my tables, including my user model. I can see the fields, and I can also see a visualization of all my data models and how they interact and connect. Finally, I can take this backend and build an entire application around it. This is like, I'm glad you like that. This is similar to a Notion clone that we created. And if you, I probably need to reload the page, but I have teams. I have multiple teams. I can go into my team settings, and I can upload a new picture. I can rename my team. And this is a full application that behaves very similar to Notion. In fact, I update the name, and you should see the name updated. So it's highly interactive and everything. And I did the front end, but the back end is fully on Keel. And we can always come to the database and take a look at that. So I changed my team name to build stuff, right? And boom, build stuff. The team name is there. So the front end and the back end did get wider with Keel. But also, my job as a front-end engineer got way simpler because I just make a front-end and connect it to this thing, this one schema file. It's kind of nuts. Also, I have to talk about AI because that's a trend. If I don't talk about AI, we're missing something. I will be very quick. This Keel schema language is a new programming language they invented for this use case, and nobody knows the language. They've been a stealth startup until like months ago, right? And I met them, and they were like, "We have this language," and I was like, "How are you going to launch this thing? Are you going to tell all the developers like, hey, all of you need to learn a new programming language?" Yuck! Nobody wants to do that. Why should they do that? And so they said yes. And so I spoke to them a little bit, and I was like, "What if we used AI?" So there's this Keel GPT. I don't know if you saw this, but OpenAI now has support for multiple custom, this is a trend also, custom GPTs. You can make your own GPT. And the way you make your own GPT is using English. If you want to create a GPT, you go to ChatGPT, you go to Explore, for example, and there's a button here that says Create a GPT. It's beta. I don't know, anyone done this before? Okay, like 2 of you, yeah. And so you literally write English. I want to make a UI assistant. I don't really know, but this doesn't really matter. And so you say what you want in English, and this AI over here on the left makes this AI. Literally, one makes the other using just English. It's kind of nuts. So we took this mechanism, and we're like, let's use it to make Keel GPT, which teaches people how to create this new programming language. So we taught the AI the programming language from scratch. Again, this could never be included in training data because it's a brand new language nobody knows. And we saw how we get. So let's do create me a schema for a to-do app, right? We'll do something like this. And it's going to think, and this again was fine-tuned, its data set to where it will create a schema for us. So I just said a to-do app, and it's already telling us you need models user and to-do item, and it's writing code here in a language that nobody knows. And now, because of this, nobody needs to learn. Unbelievable. And not only that, because a big problem with AI is what? Is hallucinations. They sometimes see things that are not accurate with reality. And there may be issues in the schema that's maybe wrong. So we then built another service that this thing communicates with and says, hey, is this valid? And then that machine talks to this machine and says, no, it's not valid. You have errors on line 3, 6, 9. And then it receives those errors, goes back and fixes it infinitely until it's valid. This is a new concept in machine learning called RLMF, reinforcement learning with machine feedback. And it's literally one machine talks to another machine, and they iterate until it's perfect. And this way, all our jobs are taken. So if we say validate this, and now it's literally just going to talk to another machine that will test whether this is appropriate or not. There's a point to all of this, and the point is we need to consider the boundaries of our work and machine work in frontend. This is the trend I'm talking about. Because HTML and CSS are specifications that have been alive for a very long time. HTML is almost as old as me. And I'm old, okay? And so a lot of the stuff can be AI assisted. It cannot be AI replaced because AIs hallucinate. But the trend is you use AI as a co-pilot as much as you can. Anyone using GitHub Copilot in your editor? Yeah, exactly. Look at the hands, right? This is a trend. And the sooner you learn to train a custom GPT and use it as your personal helper, I think the better you're going to have a leg up. So this thing is spending some time talking to the external machine. It's actually not. What it's doing is making sure all my parameters are secure. Security is really important in this space, as you can imagine. We want to prevent apocalypses. If this takes longer, we can just move forward. I think you get the idea. But if it doesn't, we can. Anyway. It's still talking. It's probably talking about to the validator, exactly. This one talks to the validator, and at some point it's going to ask me for permission. Can I share the generated schema with that thing? And then I say yes, and so on and so forth. But let's move on while this happens in the background. We may come back to this at the end. So that's one thing. Front end is discrete, back end is discrete. Second thing is the front end is becoming blurry. So we talked about how they're getting segregated with things like Keel. That's the back end. I focus on UX, UI, etc. But it's also getting blurry. And it's getting blurry because front-end engineers these days have to understand and reason about server-side concepts, things like cache control, through components like the BFF, the best friend forever, the backend for the front end. Anyone using a BFF around? Yeah, okay, great. The BFF is a trend, and it was a trend, but it's getting more dominant because of frameworks like Next.js or Remix or Astro that help offload a lot of the work to the server side so that the front-end users don't suffer long load times. A big problem on the web is that we ship way too much JavaScript. I think everybody knows this. You open reddit.com and whatever subreddit you want. Depending on the subreddit, you load around 2 to 3 megabytes of JavaScript. Megabytes of JavaScript, which you may think, okay, I have fiber to my home. I have a gigabit second download. Yes, but what about your users, though? What about your users on low-power devices? What about your users with sketchy internet access, right? Ideally, you want to make an application or an experience for all of them. And part of inclusivity and accessibility is creating experiences that are fast and accessible. Accessibility, you get it. And so the backend for the front end helps this by doing a lot of rendering work for UI on the server side and serving the leanest code to your users, okay? Some benefits of the backend from the front end, number one, they help with data fetching. So I speak at a lot of conferences. This year, this is conference number like 34 or something, this year alone. And I was in India in June at a conference, and then in October as well. And the vast majority of the code that I saw in India, UI code, unfortunately was very, very insecure. Okay? Very insecure. And the reason it was insecure was because in fetch requests from the client side, the people are including authorization headers with bearer tokens. And so I can literally go to any website from certain consultancies and just open the network inspector, inspect the request headers, go to the bearer, and you'll find like an auth0 token. And this was very common. And so if you have a BFF, you can defer that data fetching, that secure data fetching to the server side where nobody can inspect any network because it's not happening on the client side. So data fetching on the server side is huge, is a use case for the BFF. Anything secure, your front end talks to a BFF that you have, which is just a server that is dedicated for the front end, and that BFF proxies things securely. Okay? Data fetching is a trend in the BFF space. Number 2, rendering. This is somewhat new. So far, we've had the concept of server-side rendering. If you're working with something like React or Solid or Vue.js or Angular, whatever it may be, and you're entirely rendering on the client side, this is pretty bad for a number of reasons. Number 1, search engines. So far, it's debated, right? They're closed source proprietary algorithms, so you don't really know what search engines are seeing one way or another. But the lore is search engines struggle with basic HTML markup, and then if they need to load JavaScript and the JavaScript takes time, etc., you're not going to get the best SEO out of client-only rendered applications. So rendering your front page on the server side and then sending that to the client side as HTML, and then making it interactive with JavaScript later is a practice. This is server rendering a single page. This is changing at a pretty large scale, where instead of rendering entire pages on the server side, we now can render individual components on the server side. So instead of rendering your entire page to HTML on the server side and sending it to your clients, you render like just the date component. And usually you would do this because date formatting libraries are very, very heavy, large JavaScript bundles. So if you include that JavaScript bundle on the server side, format your date object to a string on the server side, and then send that to the client side as just text, you've saved a few megabytes, right? So the BFF rendering individual components, React, Vue, Angular, whatever, UI components to HTML on the server side is a trend we're seeing. And indeed, we'll look at that in a demo shortly. Finally, edge computing. We've had edge networks for a long time. We've had CDNs, content delivery networks, at the edge for a long time. Edges, by the way, are the boundary between your internet provider's network and the broader network. The edge of your network is the geographical boundary of where your ISP's coverage is. Okay? And edge networking is super useful for content delivery networks because it allows you to store like images and HTML files, anything static, any static file. You can store them very close to your users. And this matters because when you request data on the internet, it's bound by physics. It's bound by the speed of light because the internet travels across fiber optic cables. Fiber optic meaning fibers, and light travels across them. And so if we're in Lithuania and we're requesting data from Australia, that data literally needs to travel under the ocean via cables and light, okay? That geographic distance is a limiting factor in speed. If you store the data close to your users, everything gets faster, arguably. I mean, it depends on if that data has further dependencies away, etc., but that's the theory. So we could do this with static assets like files, but now we're able to do it. We're able to also do computations at the edge. That is, actually run code at the edge. And this is new, and this is a function that's happening in the BFF, as you can imagine, for speed. Okay? The conventional wisdom in the front-end world nowadays is just use a framework. People say, just use a framework. And there's a lot of debate about what is a framework and what is a library. For example, React, the most popular user interface library in the world. Some would say React is a framework. Others would say React is a library. I say, I don't care. Can I use it? Well. Just for clarity, though, a library is a collection of functions that you import into your project and use. And a framework is something with opinions. Structure your files this way. Include these files, don't include those files. So a framework is like a library, but with many opinions about your structure of code, okay? That's the difference. And because React, for example, it just exports functions and doesn't care how I structure my stuff, I would say React is a library. Doesn't matter. But this is the wisdom. And this comes out of a post on social media, X, formerly Twitter, by Andrew Clark. Andrew is one of the persons who works on React at a company called Vercel. He's literally the author, one of the authors of React, the library. And he says if you use React, you should be using a React framework. If your existing app doesn't use a framework, you should incrementally migrate to one. If you're creating a new React project, you should use a framework from the beginning. By framework, he means something like Next.js or Remix. These are React frameworks that give you opinions around file structure, data fetching, and server rendering. Okay? And so this is cool. He says this. I read this, and I think immediately, okay, but like why? And part of this talk is explaining to you this trend. This is clearly a trend. January 23rd, 2023 was when this was posted, and since then we've seen a big rise in frameworks. So then the question is, okay, but like why? Why should I care about this? One observation I just made is that I don't have a clock here. So I don't know when I'm going to go overtime. So tell me, somebody. Thanks. What? There's a clock where? Oh yeah, come on, that's an analog clock, man. I, I wanted a countdown. Okay, so
you're good. I'm following from the clouds. I am following. I'll tell you when you're late.
Is that God?
Yes. Yes, it's me.
God, can I have a Lamborghini? Okay, so
it's a little bit early for you to come to me, but you'll be there.
Great,
okay.
Great. Thanks. If you can say like 5 minutes when there's 5 minutes left, that'd be great. Okay, so framework. Why should we use a framework? Let's take a look at that. Frameworks fundamentally help with 3 things. They help with a lot of things, but mainly 3 things. Server rendering. We talked about why that's important, SEO, among other things. Data fetching, we talked about why that's important for security, among other things. And server rendering, data fetching, and code structure. They give structure to your repo, so you don't have to think about it. Let's look at that now in a demo. What we're going to do is implement a framework from scratch to understand how it works. Cool? Cool. Let's open our terminal, and we go to framework, and we'll cd, or rather, we'll run code. Anyone use VS Code here? Yeah, I love VS Code. Someone said no. What are you, a JetBrains guy? Cool. No hate to JetBrains. I just don't write Java. So we'll move this to one side. We'll move this to one side, and we'll go to localhost 5173. Of course, I need to start the dev server, so we'll npx vite. Vite is a way to bundle applications, JavaScript applications. Okay, we have this. It's a list of my favorite breeds of dogs, okay? And this is a client-only application. What's the problem with client-only applications? If I view the source of this, that's what we're sending. This is what we're sending over the network. Script tags that says, hey, load some JavaScript. And then when you load the JavaScript creates the user interface. So we'll go back to our local host. Right? So what's happening is we're loading JavaScript. JavaScript is then running to add elements to the page. And then once the JavaScript adds elements to the page, it then starts data fetching, and my data is not available to me until like so long. So like first I need to download JavaScript. If I've got a slow internet connection, I've lost already. Then the JavaScript loads, adds the basic user interface, and then it starts fetching more data. Man, that's awful, and this is why client rendering doesn't work, okay? The cool thing is there's some state here, so I can like click on things and this counter updates. That's nice, I guess, but the experience kind of sucks. So server rendering helps this. Let's look at how. We'll create a file called server.jsx. Do I have a build step, actually? Oh, I do. Wow, I came prepared. We need to say this is for Node.js. Sorry. And we'll just write a little server. Anyone write server-side Node.js ever? Okay, good. Yeah, like 3 of you. The way you do it is you need a server, so like Express. You need to instantiate that server by calling Express. Express. Okay, whatever this is, I don't want it. And then you just define paths. So app.get, and when we get the /path, that is the root, we get request and response as an object. And here I can say something like this, right? Send in the response, hello world. And then finally, I'll listen on port 3000. And when it's done, are you noticing the AI assistance as well? That's important. That's why we covered AI in the beginning. So this is a very basic server. And if we run it, let's see, can I run it like this? Let's go to my terminal, and we'll go to the framework. We'll npm run build, and we'll run the server, okay? Failed. Awesome. These platforms, oh, it's equals, right? This is so weird. You need an equal for that. Let's try again. Okay, cool, it worked. So now if I go to localhost 3000, not 5173, I will see, hello world, this is my server, it works. But what I need to do is take my application, that JavaScript application, and render it on the server side. How can we do that? We can do that with a utility called render to string from React DOM on the server, okay? And this is a function that will literally take like a tree of React components and turn it into HTML. So we'll just do that. So we'll say, instead of sending hello world, we'll take my string and we'll do render to string. And then my React app is somewhere in this code base. It's here, right? It's just a React component. Hi, everyone. Please take a look at my favorite dog. This is what we're sending React on the client side, okay? So we'll just render this. We'll import it. Come on, we'll import it. Boom. We'll render that to a string, and we'll send that instead over the network, like this. Save. Let's go rebuild that server. Okay, and now if we reload, boom, we have it. Server rendering, done. And the benefit is, what are we sending to the users? Instead of a bunch of script tags, look, We're actually sending like useful text. Search engines can see and index this stuff. That is the real value of server-side rendering. But we have some problems. For example, if we come back here from the beginning and reload, it says loading breeds, but it never updates. It never updates. And the reason it never updates is because we're rendering that initial string on the server and sending that string, and that's it. There's nothing to pick up that string. So we need to include JavaScript on the client side. And this is fairly easy to do. We just take our string, we take our string rendered by React, and we add a script tag slash client.js, literally. And this will allow clients to pick up the JavaScript and become interactive and complete that update. So we'll rebuild, we'll rerun, reload, and now it updates, right? There's still a problem though, because we're not handling asynchrony well. And also there's a big problem because we're not actually interactive. You see this? The number doesn't update. So a way we can handle all of this is rendering asynchronously. So we'll change this with pipeable stream. And this is what I'm saying. The front end and back end is getting a little bit blurry because we're on the server side, et cetera, and it's kind of back end, but it's kind of not. And we'll change this whole thing to where we get a pipe function. Streams use pipes. And we'll render our app to a pipeable stream like this. And when we have the shell of the application ready, this is all from React, by the way, then we pipe the response to the response object. Look at this. That's kind of ridiculous, if you ask me. But this is the way. And we can also add bootstrap scripts. This is just a React configuration. And we can say /client.js. And finally, we use the static directory dist. So combining all of this now, if we run build, we should have a fully interactive app rendered on the server side and now also hydrates on the client side, right? That's typically how frameworks work. They render React on the server side, and they call your data fetching functions on the server side and everything, and they just output HTML. We've talked about the reasons why this is a trend. It's more secure, it's faster, it's indexable by search engines, etc. Okay? Topic number 2. There's 3 topics. We're at 30% of the way there. This guy's looking at the clock. It's okay, man. Number 2, front end is very fine-tuned. We care a lot about performance. You know why we care a lot about performance? Let me show you. There's web.dev is an excellent resource by Google that talks about this. There's an article called Milliseconds Make Millions on web.dev. Brilliant article. I highly recommend reading it. I'm not going to read it here, but this one. A 0.1 second improvement in 4 speed metrics can improve progression rates across the full purchase funnel. What that means is, if you make a 0.1 second improvement to the performance of your application, people are probably going to buy your stuff. It's kind of ridiculous, but it's been proven over and over again. Performance matters. Therefore, a trend in the front-end world now is to make things as fast as possible, okay? And React is the de facto standard for building user interfaces. React is also the slowest way currently on the internet to build user interfaces. Any app built with React is slower than an application built with not React. And by not React, I mean Angular, Svelte, Vue, Solid, Quick. All of these are faster than React. That's just a fact. It's a fact because not because React is slow, but because React leads you to write slow code, unfortunately. The reason for that is the way React works. React uses a mechanism called the virtual DOM, the DOM, which is an abstraction on the real DOM. For those of you who don't know, the DOM is the browser's HTML tree represented as a JavaScript object. It's a JavaScript object modeled after your HTML, okay? That's the browser DOM. React copies this and makes a lightweight version of it called the React DOM, the virtual DOM. And in React, how it works is if you have a component with some state, for example, the state is my name, enter your name, right? If you have a component with that state, anytime you update the state of this component, all the components under it, going as deep as possible, they all update if the parent updates. Even if those components themselves never changed, they update. If each component is a function, then when a function at the top is called with new state, then all the functions under it recursively are called. That's why React is the slowest way. It's just a bunch of function recursion that is unnecessary often. And React does not help you memoize appropriate functions. Therefore, React apps are always, always slow. In terms of optimizing things and making that millisecond difference, there's a new trend around reactivity. How many of you have heard of signals? Yeah, okay, good. This is if you could encompass the year 2023 in Frontend, it's all about signals. Everyone's signals everywhere. And there's a reason for it. For those of you who don't know, signals are a data structure that looks like a JavaScript object, right? An object has keys and values. You read a key, you get a value. But the difference is when you read the key of a given object, of a given signal, when you read a signal, you implicitly subscribe to its value. You don't know this, you don't do this explicitly. But when you do like person.name, and person.name is a signal, then when you access that property behind the scenes, the signal will add you to a list of subscribers. Okay? And then whenever person.name changes, the signal itself will notify, the signal watcher will notify that signal where it's used, and only that thing updates. So it's not a series of recursive function calls, it's in-place, fine-grained updates using signals. And the way they work is through JavaScript proxies. I would love to get into the deep details of that. We don't have time, unfortunately, but we'll talk after if you're interested. But that's how signals work. And I'd like to show you that through a practical demo. Let's go here. I love demos. You know why? Because I get bored of my own voice. So let's close this. Actually, let's close VS Code. And we'll go to our Reactivity directory, npm run dev. And we'll go to React npm run dev. So, okay, so now we should have two applications, localhost 3001 and localhost and localhost 3000. Okay, let's go to localhost 3000 as well. That's the wrong application. Let me just restart my development server here. Okay, localhost 3000. Okay, perfect. So what we have, let's actually start these side by side. We'll go here. And what we have is two applications of counters. They're both exactly the same, except one is in React and another one is in Solid.js, which is almost exactly the same as React, but faster. Okay? Let's take a look at why by looking at the code. So if we look at the code, what we'll see is this is our application. Let's get this beside this. This is our application. So we have a counter with count, as you can see here. And we have a button, as you can see here. And we have a component. What is the component? The component is a thing that takes an array of length 10,000 and gives you a random number for each element in the array. That's this huge list here. This is component. Component is very expensive. It's 10,000 elements. What? That's a lot. So let's look at what happens when you update state in React. And keep in mind the structure. The structure is home is the top level, and under home we have component. Components props never change. Components state never changes. This is always the same. Component is always the same, okay? So in React, when we increment the counter, our 10,000 values are recomputed. Oops. Are recomputed. And that's because in React, when home changes, everything under home is updated, even though it never changes. This is the model of React. That's why it's slow. If we look at Solid, Solid uses signals, and therefore, nothing changes. The update is efficient and performant because it uses signals. In fact, if we compare the code between React and Solid, let's do that. So we'll kill the Solid server, and we'll open the code. And let's do a quick side-by-side comparison. So this is, on the left is Solid.js, on the right is React. And you can see the code is literally the same. The only difference is Solid has create signal, React has use state. That's it. The only difference is Solid, when you read a signal, it's a function call. In React, you just read a value. That's it. But the API is the same, and the difference is huge in terms of milliseconds making millions. Okay? When you call counter, what happens is you tell Solid.js, hey, I care about this value. And when you call setCounter, what it does is it does set a new value and then notifies everyone who called counter. That's how Solid works. That's why Solid is faster than React. Okay? Then the question becomes, okay, but like, do you need signals in React for React to be fast? And the answer is actually maybe not, because React exports some utilities called react.memo and hooks called useMemo. And what these do is they memoize things. In computer science, memoization means if a function receives the same inputs, you cache the output, and if it's been computed once, you just store the cached output. So you don't, even if you call the function again, if it's the same inputs, you don't do the computation, you just like return the result. Memoization, okay? React allows you to do that with components. So you can say, for example, that expensive component of 10,000 elements, I could wrap that in react.memo, and as long as its input props don't change, it's the same component. I can do that. The problem is I need to think about it, and I don't want to have to think about it. And with Solid, you don't have to think about it. But the React team is working on a compiler that will take a React project and at build time, automatically add memo everywhere that it should add memo. So you arrive at the same place as Solid without any changes to your developer experience. That's coming. It's in use actually at Meta already on Instagram and WhatsApp. They're using this, and with enough validation, they will make it open source, and we all benefit from that. That's coming. It's called React Forget, because memory forget. You get the idea. There's an excellent article about why you don't need signals in React along these lines from a great person in the community called Daishi Kato. I have no financial relationship to him or anything. I just think it's a great article. I highly recommend it. He's the author of a library called Jotai, which is a state management library. Okay? All right, that's 2 out of 3 done. We have one more. Frontend is trending towards being invisible. Can you see that? You can't because it's invisible. But frontend is trending. What does that mean? We've already talked about the fact that we ship way too much JavaScript, way too much. And the less JavaScript we ship, the faster our apps are. For multiple reasons. JavaScript requires network resources to download, so there's network I/O. And it also requires CPU resources to parse and execute. Right? There's 2 sides. So if we can reduce the amount of JavaScript we ship, we can reduce the network cost and the CPU cost. Whoa, everything gets so much faster. So this is a trend where like libraries just don't exist in the browser anymore. Everything is on the server, and almost nothing is in the browser. And this is a really cool trend. Anyone heard of Quick, QWIK? Okay, yeah, some of you. I'd say 2%, 3% of the room. Quick, QWIK comes from Builder.io. I do not work for them. I have no financial relationship to them at all. They're just friends. I just need to make that really clear. Quick, QWIK is a library that makes user interfaces as fast. Quick is the fastest way to build user interfaces on the web today, period, full stop. And I'd like to show you that and then explain some of the mechanisms, how it does that. And I think it's quite a trendy space. So if we come to our final demo, what we'll do is we still have our React demo running, but let's go to I guess my talk wasn't good enough. I'm joking. Bundle size, and we'll go to quick npm run dev, and we will load 5174. Okay, so if we go now to our browser, whoa, sorry for that. I don't mean to blind you. 5174. Okay, so this is our quick application. It's the same counter. Counters are a great example, by the way. It's a counter, and it works as a counter. Like this kind of just works as you'd expect. But this page and all quick applications on first load always deterministically load 1 kilobyte of JavaScript only. Actually, a little bit less than 1 kilobyte. Every single time you load a quick application, you can predict there's always only 1 kilobyte of JavaScript. No more. No more. It's sort of revolutionary the way they do this. And how they do it is they render everything on the server side when I request this page. But then when I go to interact with this button, let's do that again. So now this is entirely from the server side. If I come to interact with this button, when I click it, then it lazy loads the event handler of the button. Okay? Let's look at how this looks in the code, and then also let's talk through some really interesting details about this. So if we go to, let's actually open the code of this. And show you what's happening. So we have a component which has let's move this to the side. Okay, so here we have a component that loads a header and a section and so on. This is not what we're interested in. We're interested in our little counter. So if we come to here, I believe, yeah. So again, similar to the React code, we have a component with a counter. And when we on-click, we increment the count's value. That's it. But you may notice these $signs. The $sign is a signal to Quick that says, hey, when you see a $sign, the next function that comes after that, split it out into a separate file, and then only load it when you need it, when the browser requests it. Automatic. All of this is automatic. So I just write code the way I write code, and Quick does all this splitting stuff for me. And you may think, okay, that's cool, but what about if there's no network access? Well, the first time you load a Quick application, it automatically in the background loads everything it's going to import later. So it's all cached for you, okay? But the real genius, I want to show you this. So again, let's open the network inspector. We load this page from scratch, right? There's absolutely nothing loaded. So if we reload, there's some Vite developer server stuff here, but nothing more. Our component, so this little counter, because it's in the viewport, is loaded lazily. That's what we see here. But now when I go click the button, watch. I want you to pay attention to this, okay? I click the button, and you see that? Here it loaded. What did it load? Let's give us more space. It loaded routes component div button onClick. It loaded the onClick handler the moment I clicked on the button, not before. And what was inside? Well, if we come see what it gave us, let me make this bigger. It gave us a component, an onClick function, that gets count from use lexical scope and does count value. And this is the real genius because I have a closure. So if we come here, my count lives outside the scope of this function. This function references count outside its body, you see that? But some way, Quick knows the value of this count in a separate module. It's kind of ridiculous. And the result of this is massive. You know what the result is? The result is you only load 1 kilobyte of JavaScript on first load always. Your time to first byte is instant. Your users get instant UIs. And then they only load the JavaScript they need. All of us today are shipping applications with event handlers, on click, on key press, on this, on that. Our users may never click the button ever, but we still ship it to them. That's the state of front end today. But with Quick, you only ship what people need. Reddit.com ships 2 megabytes of JavaScript that I never use. Huh? And so Quick is tremendous, and it achieves this through a mechanism called resumability. Of course, he's telling me I have 5 minutes left, but I do have a deep dive into how Quick works on YouTube. I will not invite you to like and subscribe and whatever YouTubers say, because I don't care if you do, frankly. I just want to give you information to give you confidence to have discussions. Okay, that's the whole goal of this. And so there's details there. Let's wrap up with the recap. Again, it's been 40 minutes. I can't believe you've stayed for this long. Some people left, actually. But let's wrap up with a quick recap about the landscape of UI tools today for front-end engineering, for front trends. Angular just had a new major version release. Woo, Angular. Anyone using Angular? Okay, wow, awesome. Angular 17 is brand new and adds first-class support for what? Signals. I'm telling you, the year 2023 is the year of signals for frontend. Angular adds signals as the main reactivity primitive, and they really did a full rewrite of Angular with no breaking changes. But there's a lot of new things in it, and it's tremendous. Angular used to be powered by actually a library called Zone.js for change detection that was also inefficient because it just added event listeners everywhere. But it's fast and good. I recommend Angular. Let's talk about Vue. What? Oh yeah, this is the new version. Cool. I forgot I had that slide. Let's talk about Vue. Vue is also, guess what, uses signals for its main stateful primitives. Vue is similar to others in terms of performance, but its edge is that you don't need a build step. You can just include Vue in your page with a script tag from a CDN, and you're good. You don't need Babel, you don't need Webpack, nothing, just Vue, done. However, the syntax for React developers who are used to JSX is a bit difficult. So your mileage may vary, but it is, again, faster than React. React, as we've talked about, is the slowest way to build on the web today because of the virtual DOM. You're laughing, it's just a fact. But using the React Forget compiler, it's going to get the same fine-grained reactivity as signals. And the reason for this, by the way, the React team are dear friends. I'm thankful that I'm able to talk to them. I actually asked them, why don't you just adopt signals like everybody else? And they were like, we don't think that's the solution. And their stance is really cool because they believe that signals are an implementation detail, just like memo. Use memo, use this, whatever. And they're like, no, we want the developer experience where you just write code and we handle the memo. We handle the reactivity. You don't have to think about it. And Forget is a step in that direction, okay? If you haven't worked with Svelte, I've worked with SvelteKit in production. Svelte is a similar library, also uses signals as their main reactive primitive. It's called runes in Svelte. And Svelte is interesting because it is a compiler. You write the code you want, and it turns it into proper JavaScript that can scale. It's pretty cool. So it's not a library, it's a compiler and a library, but it's mostly a compiler. Solid, as we've seen, is like React, but faster, literally. It's React with signals, that's it. But the cool thing is signals they don't need to respect the rules of hooks. You can create a signal anywhere, even globally, and just consume it in your component. The difference with Solid and React is your function components are called one time. That's it. And all the updates happen in signals, not in components. That's the main difference, okay? And finally, Quick, as we talked about, is like Solid, but adds another layer of performance by only shipping the JavaScript you need on demand. Okay? That should give you a landscape of all of these. And now you might be thinking, okay, but like, how do I choose if you have to choose? Maybe you're starting a new project. How do I choose? Which one should I choose? And the answer comes from Evan You. This guy is the author of Vue.js, and he has a really great answer. He says, you don't need one tool to rule them all. Pick. They have trade-offs. Ideally, I've given you a picture of the trade-offs, and you now know what to do for what use case. Maybe React is great because you like the developer experience. Maybe performance really matters, so you'd go with Quick. It's up to you. Finally, one last note. What if you didn't have to choose? What if you could use all of them in one website? You can. There's Astro, this is the best way to build customer-facing website, not apps, probably not apps, but websites. If you're building a blog, if you're building a marketing site, Astro is the way to do it in 2023 because it is optimized for static use cases. It has full Markdown support, and it has the concept of island architecture, where your whole site is static, but little portions of your page behave like interactive islands that are interactive, because they're interactive islands. And you can build your islands using whatever you want. React, you can have an island in React, or an island in Svelte, an island in Quick. You choose. You can also decide when the islands become interactive. Do they become interactive only on the client side? Do they become interactive when somebody clicks? You get all these benefits. Astro is the best way to build websites in 2023. All right, I have a demo. I don't have time for it, but let's quickly talk about the things we didn't cover as I wrap up, okay? And again, all of this is on YouTube, X, etc. So these are all the things we didn't cover that I think is worth spending time with. v0.dev is a way to generate, it's like Midjourney, but for React components. You can generate React components with AI. Brilliant. LangChain is a way to compose multiple AIs together and form autonomous AI agents. CSS level 4 is a thing. I don't know if you know, I'm about to wrap up, I promise. CSS level 4 has first-class support for nesting. You don't need to write SCSS for nesting anymore. You can just, nesting is now native in CSS, just in case you didn't catch that. Tailwind is good, okay? There's a way to time travel debug React applications called Replay. We didn't get time to go into it, but it captures the entire JavaScript event loop. And you get something that looks like a video, but you can actually inspect the code at that point in time and change it. So Replay is cool. Tauri is like Electron, but faster and smaller because it's built with Rust. Bunch of tools, whatever. We're not going to talk about this. Let's wrap up. Takeaways. What should I do with all this information? My point here is to give you context to enable you to have confident conversations and not feel imposter syndrome. That's it. What should I do with it? What is my takeaway? I don't know. My goal is you've learned enough about React, about Astro, about Quick, about signals to have those conversations and live your best life. I will wrap up by saying I'm writing a book. This is going to be launched next year at some point about React. It's not how to use React. It's how React works mechanistically under the hood. If you're interested in how React works, this is for you. I'd plug that here as well. And finally, I may be a little bit over time. I apologize, but I want to thank you so much for having me at this conference. It's been a real pleasure.